Science is all around us. Just about every activity we do can be broken down into some type of scientific equation, and cooking is no different. Your kitchen is a laboratory, and every time you make dinner, you are conducting a scientific experiment. Here, every ingredient is a component, and every recipe is a chemical equation for a delicious way to learn about the science of cooking. To help us conduct today's scientific experiment, we've invited Chef Paula from the Florida Department of Agriculture and Consumer Services to prepare a nutritious breakfast to start the day off right.
Hi, I'm Chef Paula. With me today I have Julian and Trinity. We are making a delicious dish of Fiesta scrambled eggs with blender salsa. We've already sauteed our vegetables, so now let's scramble the eggs.
Not so fast, Chef Paula. Before you scramble those eggs, let's bring back our resident egghead, Dr. Matthew Curran, to do a recap on the difference between a physical and chemical change.
Matter can generally go through one of two types of changes, a physical change or a chemical change. When an egg goes through a physical change, its composition isn't altered. It still would have the same characteristics, the same color, the same texture, the same taste. The only difference might be the size or shape. A chemical change in an egg occurs at the molecular level, often resulting in a different color, a different taste, or even a different smell.
Okay, let me show you the correct way to crack an egg. First of all, you want to make sure that you hit it pretty firmly on the side of the bowl and that there's actually an edge so that it will crack evenly in half. And then you want to flip it over. Make sure there's nothing else in there other than nice egg white and egg yolk, and then dump it in the bowl.
Hey kids, want to earn some extra credit? Is cracking an egg a physical or chemical change?
Since the only real change that occurred was the cracked shell, this is actually a physical change.
So now we're going to whisk the yolks, breaking them up until they become a pale yellow color. Keep whisking so that we incorporate air to make them light and fluffy.
More extra credit. Is whisking a physical or chemical change?
Now this is a tricky one, because even though there appears to be a change in color, this is actually a physical change. The yellow color of the yolk is simply overriding the egg white color. It's like mixing yellow and blue paint. You get green. Or, more related to this example, mixing yellow and white paint, you get a lighter yellow. We could have an entire class discussing where color comes from, but we'll save that for another day.
Okay, and while we're whisking, we can go ahead and add the milk. We've got half a cup of milk. And we'll whisk that a little bit. And now we're just going to add a little bit of salt and a little bit of pepper.
Look at the combination of eggs, milk, salt, and pepper. After Chef Paula whisks them all together, is a mixture or compound created. Remember, when two or more ingredients are chemically bonded together in fixed ratios, a compound is formed. However, when two or more substances are combined together, but the ratios of components can change, a mixture is formed. Now, to make things even more complicated, here's Dr. Matt.
Yes, it may be more complicated, but it's important. There are two types of mixtures that we deal with. Homogeneous mixtures, meaning they are the same throughout, and heterogeneous mixtures, meaning they are not the same throughout.
That being said, is a mixture of milk, salt, pepper, and eggs a homogeneous or heterogeneous mixture?
Well, even though the ingredients appear to be inseparable, this is actually a heterogeneous mixture because they are not evenly blended throughout. You can actually see it visually with the pepper flakes scattered throughout the egg. They are not evenly distributed throughout the mixture.
So now we're going to let these sit here for a little bit until they start to get a little bit firm on the bottom. And then we're going to take our spatula and slowly scrape to make the large curds.
Curds?
When you're cooking scrambled eggs, you don't want to cook it on high. You want to have it a nice medium to low temperature. You don't want to brown the eggs. You want to make sure that you have nice large curds with this light yellow color.
More extra credit? Is cooking eggs a physical or chemical change?
This is another tricky one, folks. When the egg mixture starts to set, it actually goes through a phase transition, from a liquid state to a solid state. It's similar to the phase transition that melting butter would go through, only instead of going from a solid to a liquid like butter would, the eggs go from a liquid to a solid. This is an example of a chemical and a physical change occurring simultaneously. If you think about it, the eggs are liquid when poured into the pan and then changed to a solid upon heating. If it was a true physical change, the eggs would melt back to a liquid once they cooled. But we all know they don't. This is because the heat causes a chemical change, which happens to result in a physical change at the same time.
All right, I think we're ready to add the cheese. We've got about a 1/4 cup of cheese. We're just gonna add that in, let it melt a little bit. And now we're gonna add the sauteed vegetables in. Delicious, fluffy, healthy, colorful Fiesta scrambled eggs. So now that we're done with the Fiesta scrambled eggs, next time we're gonna make blender salsa.
Thanks, Chef Paula. That's all the time we have for now. We now know more than we want to about phase transition and the difference between a compound and a mixture. But those are just a few ingredients in the science that goes into preparing a meal. Be sure to join us for the next episode of The Science of Cooking.